Use cofactor expansion to compute the determinant of the following 4x4 matrix A. So again, when you are deciding what type of cofactor expansion to apply, we always want to note where are the most zeros, what's going to be the easiest for us to calculate. And so looking at this beautiful given matrix here, I'm observing that the third row has the most zeros. Again, other rows and other columns, all of them will work in fact, but we don't want to be here all night, right? We want to be easy on ourselves. So look for the most zeros. What's going to simplify your calculations? So what I'm going to do here to find the determinant of A is apply cofactor expansion across row 3. And so we know by definition here that this is the determinant of matrix A. And I have the entry in the third row, first column, multiplied by the corresponding cofactor, plus the entry in the third row, second column, multiplied by its corresponding cofactor, plus the entry in the third row, third column, multiplied by the corresponding cofactor, plus the entry in the third row, fourth column, multiplied by its corresponding cofactor. And again, the reason we picked this is because these last 3 entries in the third row, second column, third row, third column, third row, fourth column are all zeros. Pew, pew, pew. So they disappear, and we are left here with the entry in the third row, first column. We have -1 raised to the 3 plus 1, which is 4, multiplied by the determinant of the submatrix A sub 3, 1. Okay, we know that goes to 1, so we're ready to start calculating. So we have that the determinant of matrix A is equal to the entry in the third row, first column, which is 2, multiplied by +1, times the determinant of our submatrix, A sub 3, 1. So to determine this submatrix A sub 3, 1, we want to eliminate the adjacent column and the adjacent row. And so this leaves us with a 3 by 3 matrix, 0, 0, 5, 7, 2, -5, 3, 1, 8. So, looking at this, we realize we need to apply cofactor expansion a second time. Because we're always trying to reduce down to the 2 by 2 definition of the determinant. So again, we want to do the same thing that we did at the very beginning, is looking at this submatrix here, which row or which column contains the most zeros. So we can see that row 1 has the most zeros. My goodness, most zeros. So we will apply another cofactor expansion. So cofactor expansion round 2 across the first row. So again, we'll think about our definition here. So we can say that this is equal to, just don't forget that 2 on the outside. And what's nice is that those first 2 entries are 0. So we can think of this as 0 plus 0 plus the entry in the first row, third column, multiplied by its corresponding cofactor. And we're ready to get going. So this leaves us with 2 multiplied by the entry in the first row, third column, which is 5, multiplied by -1 to the 1 plus 3, which is 4, And then we are multiplying by the 2 by 2 determinant created by eliminating the adjacent row and column. So that's the determinant, or the 2 by 2 matrix, or the determinant of the 2 by 2 matrix, 7, 2, 3, 1. And so this is leaving us with, we have 10 multiplied by 7 minus 6 for a beautiful final answer of 10. And so therefore the determinant of our given matrix A is 10. And again, keep in mind this is not an exclusive way to find the determinant here. There's others that exist, but I encourage you to be easy on yourself. Right? Look for the solution with the easiest computations.